Alright, hey, let's do one more video. I owed you page 122 because when I made the older videos during COVID, we skipped page 122, but we're not skipping it anymore. So y'all have to do these proofs. So it says you're given that angle S is congruent to angle V, and you have to prove that the triangles are similar. So, okay, I'll start with the given like I always do. Angle S is congruent to angle V. That's given. And we know that typically to prove that the triangles are similar, oftentimes we end up just using angle-angle, which means all I need to get there is a second pair of congruent angles, and I hope it's obvious by now that we've always got vertical angles to use when we have vertical angles. And here they are, right there, sitting there. So I could call it angle STX and VTU. That sounds like a lot of work. I'm just going to put a 1 and a 2, and we'll say angle 1 is congruent to angle 2. It's by the vertical angles theorem. And since I now have my two pairs of congruent angles, I can say that triangle STX is similar to triangle VTU. And remember, if they're giving it to you, then yes, just copy it down. You don't have to spend a lot of time trying to figure out the right order of the letters. It's given to you in the right order, so just copy it down. All right, that's number 1. Number 2 is different because for number 2, they're actually giving you a pair of ratios. So the first ratio is talking about MR to MN, so that's this segment to this whole segment. So that's a pair of sides of the small triangle and the big triangle. And it says that that ratio is equal to the ratio of this guy, MT to MP. So that's two S's. So I got a strong suspicion we're either going to be able to get a third pair of sides and use side-side-side similarity, or we're going to be able to find a pair of angles in between the sides and just use side angle side. And of course we can get the angles. We can just say that angle M is congruent to itself because they share angle M. So we can use reflexive property. So that'll be line 2. We'll say angle M is congruent to angle M. Anytime you're saying that something's congruent to itself, that's the reflexive property of congruence. Alright, and I skipped over line 1. But line 1, of course, is just going to be to state the given, even if it just looks like a bunch of weirdness. This isn't weirdness. They're saying that MR divided by MN is equal to MT divided by MP. Now that's just given information, but that literally puts one pair of S's in our, in our pool of stuff. We've got one pair of S's, now we've got a second pair of S's, and of course we already found our angles. So we now know that we can say that the triangles are similar. It's going to be because of side angle side similarity this time. And again, just copy it down. MRT similar to triangle MNP. And that's it for number 2. For number 3. So it looks like there's some parallel lines this time, but this proof is really similar to the ones we just did on the practice, so this shouldn't be bad. But we'll say GH is parallel to ED. That's given info. So using those parallel lines, I've got this one and this one. That means I have access to a couple of pairs of angles. I could either say that angle G was congruent to angle D. Now be careful. It looks like they're 90-degree angles, but we can't assume they're 90. But we do know that they're the same because they're alternate interiors. And I can call them G and D, so I guess I will. Instead of numbers. You can also just number them 1 and 2. But I'm going to say angle G is congruent to angle D by the alternate interior angles theorem. Now if you want to use alternate interior angles again, then you can go for H being congruent to E. But I think I'm going to take the easier way out and just recognize that we've got vertical angles in the middle, of course. And I'll name them 1 and 2. And I'll say angle 1 is congruent to angle 2 by the vertical angles theorem. And that's it. We can now say that the triangles are similar. So triangle GHF is similar to triangle DEF by angle similarity. And I think that's about it, because I think I told you not to worry about number 4. Number 4 had issues where, yes, we knew that the blue and the blue were in the same ratio as the yellow and the yellow, but then we couldn't get at the pink angles that fell between them. So we didn't have side angle side. We had angle side side, which is not a valid way to prove that the triangles are similar. So we really couldn't do that proof. And then 5 was just a little more complicated than I think you guys needed to worry about. So if you want to skip 5, you may do so. And then there's a second number 5, which says Brian and Cindy each drew triangles that had 30-degree angles in them. Under which condition would those triangles be similar? And it says if they're both obtuse. Well, that's not true, because you could have somebody with a 30-degree angle and then a 100-degree angle, but somebody else could just as easily have one where this is 30 and then this angle is 100 and 5, and then those triangles would not be similar. So it ain't that. It says if the triangles have the same area. Well, no, the area doesn't really control the shape at all, so that's not right. D says if the triangles have the same perimeter. Well, they shouldn't have the same perimeter if they're trying to be similar. One perimeter should still be bigger than the other, so D is silly. So obviously it's C, if both are right triangles. And that just, well, if you tell me they're both right triangles, then I've got a right angle and a right angle. I've got a 30-degree angle and a 30-degree angle, and that sounds like angle similarity to me. So C leads us directly to angle similarity, and we know that we're similar. Oh, that's it. All right, great, we're done. Then you now have all the homeworks. You now have a quiz review, tons of videos to watch. You even have a Delta Math that you can practice along with. So get studying and do the best you can. Bye. See ya. Bye. See ya.